we are learning about LDA, stands for Linear Discriminant Analysis. Okay. It is basically a dimensionality reduction technique. LDA is almost like PCA, but it focuses mainly on the area that maximizes the separation between multiple classes. I will write down here. LDA is similar to PCA, but focuses on the area that maximizes separation between multiple classes. Okay. So the main goal of LDA is to project a feature space, of n dimensions into smaller subspace, and let's call this subspace K, while also maintaining the class info intact. So in simpler terms, the main goal of LDA is to project the features in a higher dimensional space into a lower dimensional space. So let's see an example to understand LDA better, how it is calculated. And by the way, all these calculations are automatically performed by scikit-learn. I'm just telling this to make you understand how it actually works in the background, right? For example, let's say we have classes C1 and C2 of X1 and X2 features, right? X1, Y1, X2, Y2, and we'll take an example sample space for 1, 2, 4, 2, 3, 6, 4, 4. Okay. And in second class, we'll have 9, 10, let's say 6, 8, 5, 8 and 7, 10 and 8. Okay. I think that's enough. So the first step in LDA would be compute within class scattering matrix. Class scattering matrix will be denoted by SW. So the first step is compute within class scattering matrix. Matrix SW. Okay. So SW formula will be S1 plus S2. S1 will be the covariance of class 1, and S2 will be the covariance of class 2. If you remember from statistics, you will know that the formula of covariance will be, let's write it for S1, the sum of X minus mu1. Mu will be the mean, X minus mu2 or transpose. Now, let's calculate the mean. Mu1 will be the 4 plus 2 plus 2 plus 3 plus 4, 5, comma, 1 plus 4 plus 3 plus 6 plus 4 divided by 5. Next page. So I'm not going to tell you the additions and multiplication. I've already calculated them before, so I'll just directly write the results. Results will be 3 and 3.6. And in the same way, if we calculate the mean for mu2, it will be 8.4 and 7.6. Right? And now, the S1 formula, if you remember, let me write it again. S1 equals to sum of x minus mu1 into x minus mu2 whole transpose, and the value of mu1, we got it as 3 and 3.6. Right? Now we'll compute this value, x minus mu1. That would be, remember the values from our data set, that would be 4, 2, 2, 3, and 4 from x. Let me write them here. 4, 2, 2, and 3, I think. 3 and 4. Now, what we are going to do is we are going to subtract 4 from the values of our mean. 4 minus 3 will be 1. Next, minus 1. Next, minus 1, 0, and 1. Right. Okay. So what I did here basically, 4 minus 3, 2 minus 3, 2 minus 3, 3 minus 3, and 4 minus 3. Next, in the same way, we do it for 4 minus 3.6, 2 minus 3.6, 2 minus 3.6, and so on. So the values will be minus 2.6, 0.6, minus 0.6, 2.4, and 0.4. I hope you're following, right? Are you following, guys?
Yes.
Okay, cool.
Yeah.
Now, since the formula is whole transpose, let me write the values one more time. 1, minus 1, minus 1, 0, and 1. Minus 2.6, 0.6, and minus 0.6, 2.4, and 0.4. Okay. These are the values. Now, if we calculate them, let's calculate them separately and then add them. 1 minus 2.6, and we multiply it with 1 and minus 2.6. So we take the dot product and we'll get the values. 0.6 minus 2.6, 6.76. Okay, in such a way, we calculated for all of these values and we get different results, right? Minus 0.4, 2.16, and so on for all the 5 results. And we add all of these results because if you remember the formula, it is sum of all of these values. Now, after all of adding all of these values, the value of S1 will come out to be 0.8, 0.4, 0.4, 2.6. Okay, this would be the value of S1. In a similar way, we calculate S2 as well. 1.84 minus 0.04, minus 0.04, 2.64. Now, the actual formula of step 1, what we discussed, SW will be equals to S1 plus S2, right? Let's set it aside for now. Now, step 2. Step 2 will be compare between class of scatter matrix. Scatter matrix will be denoted by SB So compare between class scatter matrix. So the formula will be the same again, mu minus mu2 and 1 minus mu2 will and whole transpose. If you calculate it with the same data set in a similar way by taking mean of all the data points from the first set and the second set, you will finally get some values, something like this. Okay. Now we have the value of SB. We have the value for SW. Now let's go to step 3 in LDA calculation. Step 3 will be find the projection with the formula on the projection. And we have a formula for this step, which is SW inverse multiplied by SB that we have just calculated minus lambda I equals 0. This lambda is the eigenvector. I will explain what this is at the very end of the video. And I will be the identity matrix. So luckily, you don't have to calculate any of this because, again, scikit-learn will take care. Now the values will be, don't be scared of the values. I have just calculated them previously because it will take a lot of time to do it. So after doing this, you will end up with this equation. And if you solve the equation, you will get the value of lambda. And if you get 2 lambda values, you select the maximum lambda value. And then in the next step, let me write the values again. We have 11.9, 5.08, 8.9, 7.76. So after we get the lambda value, which is the eigenvalue, we multiply it with V1 and V2 and equate it with the value of the eigenvector. It is just a mandatory step to find out the values of V1 and V2. And if you solve the equation, you will get a quadratic equation, and then you will end up with the values. Something like this. Right. Now, step 4 is dimensionality reduction. Now, this is a completely automated process, which means it has a formula that is y equals W transpose X, where W is the projection vector and X is the input data sample that we have from our data. So after we calculate this dimensionality reduction, we will end up with a graph that is something like this. Assume these are 2 different data points with our line. And this projection is corresponding to higher eigenvalues. Or the graph could be this as well. So this is how you calculate LDA, but The main difference between PCA and LDA is the basic learning approach. While PCA is unsupervised, LDA is supervised. PCA basically, it is a linear transformation technique. It basically reduces the number of dimensions by finding the maximum variance. But LDA, it takes labels into account when reducing the number of dimensions. I will write the differences as well. PCA, LDA. This is unsupervised, and supervised. PCA basically reduces the number of dimensions by finding maximum variance. This takes class labels. This involves class labels to reduce number of dimensions. Next, PCA basically reduces dimensions by looking at the correlation between the features. By looking at correlation between features. Basically, PCA generates components based on the, we can say, direction in the data where there is most variance. For example, where the data is most spread out, PCA looks for that point in our data. And that point or that component is referred to as eigenvectors or principles, we can also say. So eigenvectors basically represent the subset of data where there is most variance in the data. And LDA also does kind of the similar thing, but it contains an extra step, which is a pre-processing step by calculating the mean vectors, which I showed you earlier. So yeah, that is basically about PCA and LDA. If you have any questions, you can ask me. And one more thing. PCA should be used when number of samples per class is less, and LDA works better with large data sets, which has multiple different classes. I will write that down as well. PCA, when number of samples per class is less, and LDA when works better with the large data sets with multiple classes. Okay. That's all I have to say. If you have any questions, you can ask me.
Okay, can you just share the screen again so that I can just take some photos?
I think I just stopped sharing. I don't think it will come back.
Oh,
I'm really sorry. Sorry about that.
Okay, then
you
can you
can.
then send the recording then so
Yeah,
that I can?
Yeah,
you can,
I'll do that. I'll send you the recording. You can
Okay.
see it from there.